So before we get rolling with new material today, I do want to make a note on scheduling. With the holiday coming up, we do have some days that we are not going to be in session. Obviously, this Friday, which is April 7th, is a holiday, so there's no class. And then next Monday, what was that, April 10th? There's also no class because it looks like all three of you guys are off on Monday. At least two out of the three of you are off on Monday for extended Easter holiday that day. I had mentioned the last class that the test was scheduled for next Friday. That's not true. I had forgotten about Monday being off. So the Unit 3 test will be coming up on April 17th. So that'll be a Monday coming up. I'm not a big fan of tests on Monday, but that's just the way the schedule fell this year for us. And we want to get to it so that we have time to get through all of the intermediate algebra and statistics stuff for the last couple of units of the course. So this is the big one, Unit 3 dosage calculation test coming up on the 17th. That's really kind of the heart of the course for us. So anyway, back into our material. When we left off on Monday, we had mentioned, we'd actually started an example of dosages based on weight. And we say based on weight just because that's the traditional way of saying it, just like we still say a weight in weight or weight in volume concentration, even though the units we're actually using are mass units. We're actually calculating based on the mass of the patient, not the weight. We're just keeping that traditional vocabulary in there. And so this is the start of doing dosages that are based on the characteristics of the patient. It's not just an absolute pure dose where it's just the dosage and that's it. It doesn't matter what the characteristics of the patient are. So we're dealing with dosages based on weight. Typically, our doctor's order will be something simple like just administer the recommended dose. Let me write that so it's readable. Now, they could get more specific than that. They could specify administer the maximum recommended dose or the minimum recommended dose, or they might even specify a time frame. For these first couple of examples, we're just going to say administer the recommended dose, period. And then we're going to look up a reference which gives us the recommendation. And typically for dosages based on weight, the recommendation is going to look something like this. We're going to have a minimum and maximum. So in this case, let's say we're going to do 18 micrograms to 20 micrograms. And it specifies per kilogram. And then usually there's going to be a time frame involved. So per hour. Because most of these dosages are going to be repeated dosages, we need to know how often we are allowed to administer that dose. Now, the per hour here that's all it's telling us is that we can administer this dose every hour to this patient if we would like to, or we can group it up to longer time frames. That time frame, however, does not take part in our calculation for most of the calculation. We will come back at the end in some cases and consider it. For right now, it's not part of our calculation. We just have that there. We keep that information. It's not useless information by any means. We keep it there so that we know that we can do that every hour. And it will be part of our answer, but it doesn't affect the calculation at all. So then we also need to know the patient. And I'm going to give the patient in pounds. So 143 pounds is our patient. As we mentioned on Monday, this recommendation, of course, is per kilogram, not per pound. So the first thing we have to do is convert the patient's weight from pounds into kilograms. 143 pounds, we put that over 1, and our conversion factor is that it's 2.2 pounds per 1 kilogram. And now that 2.2 is approximate. It's really 2.208, somewhere like that. We just use 2.2 is close enough for our dosage recommendations. We're going to do this calculation often enough. We see here that the pounds cancel out, and we're just going to divide by 2.2. And so since we're going to do this so often, rather than writing out the full dimensional analysis conversion like this, we're going to start just dividing by 2.2 to convert those pounds into kilograms. So 143 divided by 2.2 gives us 65 kilograms. So that's where the real calculation here begins, is with a patient with a weight of 65 kilograms. So I'll do that, 65 kilograms over 1. And now we have two choices here. We can either go with the minimum recommended dose, or we can go with the maximum. Now, in most cases, we start out with the maximum because the first thing we want to do is make sure we didn't overdose the patient, that we didn't exceed that maximum. So we usually find that first, especially if we're double checking a doctor's recommendations to make sure that it's a safe dosage for the patient, which is one of the things we'll look at next week. We first want to make sure it's not overdosed, and then we'll come back and look at the minimum dose to make sure that it's not too small to be an effective dosage. So we're going to start with that maximum dosage. In this case, 20 micrograms per kilogram. So I put 20 micrograms up here over 1 kilogram. So the kilograms will cancel out. We're now in micrograms. Now, one thing I have not put up here yet that I should have is the label. The label on the bottle tells us that this is constituted as 25 milligrams in 4 milliliters. It is a liquid medication given either through injection or orally, doesn't matter in this case. So we have to figure out how many milliliters we're going to administer to the patient, which means we have to get 2 milliliters from micrograms. And right now there's nothing else in this information with micrograms in it. So we're going to go ahead and get rid of micrograms and go to milligrams. This is one of those conversions that we just need to know that 1 milligram is 1,000 micrograms. And the micrograms cancel out. So now we're in milligrams. We can go that last step. 25 milligrams goes on bottom so that they cancel out in 4 milliliters. So now the milligrams cancel out. Our only units left is milliliters. That is what we want to administer to our patient. So we're going to go ahead and multiply the stuff on top there. 65 times 20 times 1 times 4 is 5,200 milliliters. On bottom, 1 times 1,000 times 25 is 25,000. This is going to become quite a small dose, but the recommendation in micrograms per kilogram, obviously those are pretty small units. So let's go ahead and divide the 5,200 divided by 25,000. Gives us 0.208 milliliters. Now remember, this is where the time comes in. It's per hour. So 0.208 or 0.21, depending on where we went around it. For this class, we're going to go to those 3 units, 3 digits for a liquid medication like this. We can round it down as needed. Remember, for drops, it's 2 digits we round to. For milliliters, we'll go to 3. And that is per hour, every hour. That, recall, is the maximum dosage, the maximum allowable dose or recommended dose. We want to create a range here, so we also want to find the minimum. To find the minimum dose, we're going to use that process that we briefly looked at on Monday called the titration. And the titration is just a process that allows us to change one of the parameters of the calculation without having to redo the whole calculation. And if you recall, in this case, we'll take the maximum dose, the 0.208 milliliters per hour, and we're going to multiply it by a ratio. And in the bottom of this ratio is the parameter that we used. Whatever goes on bottom here has to be the parameter that's connected with this number. Whatever goes on top is the parameter we want connected to our result. So here we used the 20 micrograms per kilogram. That's going to go on bottom because that's where the 0.208 milliliters per hour came from. And we want to adjust that to the minimum of 18 micrograms per kilogram. So that's going to go on top. Move this out of the way so it's not clogging it up so bad. Now, one of the things we had mentioned was that these two units here have to be the same. And they are. Both of them are micrograms per kilogram. They have to be that way because the units have to cancel out here. This is simply an adjustment factor. Should not affect our units at all. So now we take our 0.208 milliliters per hour. We multiply by the 18 on top and divide by the 20 on bottom to get 0.1872, which will round to just 0.187. And the units are still this unit we started out with, milliliters per hour. So what that is giving us is a recommended range of 0.187 milliliters per hour to 0.208 milliliters per hour. So as long as we're somewhere in that range, this is a safe dose, or it's within the recommendations, I should say, for that medication for this patient. Let's go through one where we have this whole process all at once. So our order one, once again, is to administer the recommended dose. So again, that's telling us, look at the recommendation either on the label or in a reference, some sort of medical reference or whatever, telling us what safe dosages are. In this case, it's 8 to 10 milligrams per kilogram per 8 hours. So there's a change here. This is 8 hours. Up above that was per hour. So now, again, the 8 hours doesn't come into play in most of our calculation here, but we do want to make sure that is labeled in our answer so that we know that how often we can administer that recommended dose once we've calculated it. Our label, or the supply, says it is constituted 18 milligrams in 5 milliliters. And then, of course, we have our patient, who in this case weighs 44 pounds. So once again, our first step is to get that patient converted into kilograms. So we're going to take the 44 pounds and divide by 2.2, which will give us 20 kilograms. That's where we're going to start our calculation now for our dosages with the 20 kilograms. Remember, these are dosages based on a characteristic of the patient. That is the characteristics of the patient that we want to use. So we're going to start out with 20 kilograms, and we'll put it over 1. Looking through again, we're going to use the maximum recommended dose. In this case, that is the 10 milligrams per kilogram. So kilograms have to go on bottom so that they'll cancel out. It's 10 milligrams per 1 kilogram. So the kilograms cancel out, we're now in milligrams. Next, we want to get rid of the milligrams to get into milliliters. So I'll put milligrams on bottom here. I have 18 milligrams is equivalent to 5 milliliters. So our milligrams cancel out, and we're ready now to calculate. We're in milliliters, and that's being a liquid medication. That's what we're going to administer to the patient. So on top here, we have 20 times 10 times 5, 1,000 milliliters. And on bottom, 1 times 1 times 18 is 18. So now we have to divide that out. 1,000 divided by 18 gives us 55.56 milliliters. Now here's again, we have to remember that one thing that we ignored in the beginning, that is the time frame. That is every 8 hours. So this is per 8 hours. And once again, we have to remember that this is the maximum dosage. Find the minimum. We once again will resort to that titration. So we start with the 55.56 milliliters. Now I'm going to leave the per 8 hours off of this unit because I don't want the number of 8 to confuse the calculation, because it is just part of the unit. Then in my conversion factor, or my conversion ratio here, I used 10 milligrams per kilogram to make the calculation. So that goes on bottom. And I want to convert to the minimum of 8 milligrams per kilogram. So once again, these units are the same, so they cancel out. We're going to take our 55.56, which I just left in my calculator so I don't have to write it down and type it back in. One thing that's a good practice to get into in calculating is keeping numbers in the calculator, because every time you write a number down and type it back in, there's a chance that you're rounding that number off. Here's a prime example. There was no way to write this down and type it back into the calculator without having to round it off at some point. So we take our 55.56 times 8 divided by 10, and we get 44.44. That unit is still milliliters, and I'll put the time frame back on there per 8 hours. So our range here, our recommended range for this medication for this patient is anywhere between 44.44 milliliters every 8 hours to 55.56 milliliters every 8 hours. Up to this point, our orders have been to just give the recommended dose. They've had no specifications beyond that. Like we said, they could recommend give the maximum recommended dose or the minimum recommended dose. We would just then pick the max or minimum in our desired range to that calculation. We wouldn't have to do the whole range. The other possibility is in this one, the order is to administer recommended dose every 6 hours. So now the doctor has included a time frame on their order. They want this patient to receive medication every 6 hours. We need to make sure that matches up with the recommended safe dosage for this medication when we look it up. If it does not match up, we need to make sure that we can adjust that. So we look up the recommendation. Again, this is either on the label of the medication or in some sort of medical reference. And in this case, our recommendation is to give 4 to 5 milligrams per kilogram every 8 hours. One thing you might have noticed already is this time frame is not the same as the time frame the doctor gave us. As a general rule, we can administer a medication in shorter intervals more often than recommended, and basically giving a smaller dose more often. But it's not always safe to go the other direction, to give a larger dose less frequently. If we can give 100 milligrams every 8 hours, that does not mean we can give 300 milligrams once a day. because that one single dose might be too much of a shock to the system. So if that were the case, we would have to go check or get some confirmation on that. But in this case, we're going from a larger dose every 8 hours to a smaller dose every 6 hours. We can always safely do that. So then our label, is telling us that this medication is constituted with 25 milligrams in 12 milliliters of fluid. And of course, we have a patient. And in this case, our patient is 99 pounds. So once again, we will start out with that 99-pound patient. And we'll divide by 2.2 to get kilograms. Giving us 45 kilograms for our patient. So again, that's what we will use to start our dosage calculation. 45 kilograms over 1. Once again, we will select the maximum dose, the 5 milligrams per kilogram. So we're putting kilograms on bottom. It's 5 milligrams on top per 1 kilogram on bottom. The kilograms cancel out. We now have milligrams. Next, we're going to get rid of milligrams. So we're going to put milligrams on bottom here. We have 25 milligrams in 12 milliliters. So 25 milligrams, 12 milliliters will go on top. So the milligrams cancel out. We now have milliliters as our units on top. And again, that's what we're looking for, is how many milliliters to administer to the patient. So on top, we have 45 times 5 times 12, giving us 2,700 milliliters. On bottom, 1 times 1 times 25 is just 25. So we divide that out. Divided by 25 is 108. This is 108 milliliters. And now we need to bring our time frame back into it. That's this right here. We calculated this off of this recommendation, the 5 milligrams per kilogram. So it's that time frame of per 8 hours that's attached to that. That is what we have attached to our calculation right now. But the doctor ordered us to give the medication every 6 hours. So the first adjustment we're going to make is to change that time frame. So we're going to take that 108 milliliters. This is currently calculated every 8 hours. And we want to change it to be every 6 hours. Now again, you notice these units are still the same. They're both hours, they cancel out. We take the 108, and we're going to times 6 and divide it by 8 to get 81. This is now 81 milliliters, and we have changed the time frame from 8 hours to 6 hours. So this is now every 6 hours. And again, that is the maximum dosage for the 6 hour period. We'll find the other end. We'll find the minimum. We take that 81 milliliters every 6 hours still. And we're going to use, that was found using the maximum dose of 5 milligrams per kilogram. And we want to change it to the minimum dose, was 4 milligrams per kilogram. So again, these units are the same. They cancel out. We take our 81 times 4 divided by 5, and we get 64.8. That is milliliters every 6 hours again. That is our minimum dose. So we combine those to get that our range, the recommended range for this patient would be from 64.8 milliliters every 6 hours to 81 milliliters every 6 hours. So you might wonder, how do you know whether you want to stay towards the bottom end or the top end of that range? One, it depends on what the medication is for. If it's a pain medication, generally you start towards the lower end and then you'll up it if the patient expresses need for a heavier dosage. And really, I'm not a medical expert, I'm the numbers guy. It depends on what the application is. In some applications, you start with a larger dose and cut it back. If it's a blood thinner or whatever, and we need to get the platelet counts or whatever to a certain level, you start with a higher dose and you adjust it down to a dose which still maintains that without overdosing the patient. Like painkillers, you start at the lower dose and you adjust up. For our purposes, we're just creating the range, and we'll worry about the logistics of it when you get into a more of a CNA class or a healthcare class. Now that we've seen a few examples of that calculation, I'm going to have you try one in your notes quick. So we're going to have our order is going to be to administer the recommended dose. Here's the important part, every 4 hours. And the recommendation is for this medication is 45 to 50 micrograms per kilogram every 8 hours. Our label says that this medication is constituted with 12 milligrams of medication in every 5 milliliters of fluid, and our patient is 165 pounds. So we'll give you about a minute and a half here, work through that, see what you can come up with. Okay, you might not be totally done, but let's go ahead and take a look and see how you're doing with this one. So the first step is to convert the patient weight from 165 pounds into kilograms. 165 divided by 2.2 gives us 75 kilograms. So we'll start our calculation with 75 kilograms. Put that over 1 so that we can do our dimensional analysis. Next, we're going to get rid of kilograms. And we're going to use the maximum again, 50 micrograms per kilogram. So the kilograms cancel out. Now again, we don't have micrograms anywhere else in our problem, so we're going to get rid of micrograms and go to milligrams. So micrograms to milligrams. 1 milligram is 1,000 micrograms. Micrograms cancel out. We're now in milligrams. We have to get rid of milligrams. We have this here of 12 milligrams in 5 milliliters. So the milligrams cancel out, and we're now in milliliters, which is where we wanted to be. So we do 75 times 50 times 5 milliliters is 18,000 It is 18,750. That seemed a little big for some reason. Milliliters over 1 times 1,000 times 12 is 12,000. And we divide that out. 18,750 divided by 12,000 is 1.30. Oops, 1.5625. So 1.56. I hit enter twice. That's what happened. This is milliliters. Now we need the time frame from the recommendation was every 8 hours. Now the doctor's order was to administer the medication every 4 hours. So the first thing we have to do now is to adjust this. This is our maximum dose, but it is maximum for 8 hours. So we need to adjust it to be 4 hours. So 1.56 milliliters, that's per 8 hours. We want to change it to 4 hours. Hours will cancel out. 1.56 times 4 divided by 8 gives us 0.78 milliliters, and that will be every 4 hours. So we have that titrated down to the proper time frame for the doctor. That again is the maximum dose. We want to change that to find the minimum. We'll take 0.78 milliliters. And that was based off of 50 micrograms per kilogram. And I want to adjust it to be based off of the minimum, which was 45 micrograms per kilogram. So once again, these units are the same, so they cancel out. We'll take our 0.78 times 45 and divide it by 50, which gives us 0.702. That'll be milliliters every 4 hours. So our allowable range here is to be 0.702 milliliters every 4 hours to 0.78 milliliters every 4 hours. So our next example, we're going to look at what happens if this is administered over time. So in other words, through an IV. So our order from our doctor is to administer the recommended dose again, but it is through an IV. So intravenously. So let's look at our recommendation then when we look this up for this medication. Our recommendation here is to be 14 to 15 milligrams per kilogram per 12 hours. Our label on the bottle is telling us that this is constituted at 25 milligrams in 8 milliliters of medication. We have a patient that is 132 pounds. So as always, we start by converting the patient into kilograms. Take 132 divided by 2.2, giving us 60 kilograms for that patient. And that's where we will start our calculation for our dosage. So we have 60 kilograms, and we'll put that over 1. Getting rid of the kilograms here, we'll use the maximum dose, which is 15 milligrams per kilogram. Kilograms cancel out. Want to get rid of milligrams? 25 milligrams in 8 milliliters. Now, normally this is where we would end, but we want this through an IV. So we need more information to get this set for an IV. one of the pieces of information we would need would be a drop factor. So for this medication, the drop factor on the bag, again on the label, is 15 drops per milliliter. So let's continue our calculation to figure out how many drops of medication this would be. So milliliters on bottom, and that is 15 drops per 1 milliliter. And the milliliters cancel out. So now on top, we do have drops. So we're going to do 60 times 15 times 8 times another 15 gives us 108,000 drops. On bottom, we just have 25. So we'll divide that by 25. Give us 4,320 drops. Now, when we take into account our time frame, 12 hours, this turns it into a flow rate. We have the 4,320 drops over 12 hours. But remember, we want our flow rate to be drops per minute. When we typically set up an IV, drops per minute is our standard setting. So the drops are going to change. I want to get rid of the hours. 1 hour is 60 minutes. So the hours will cancel out, and we'll go ahead now and multiply this out and then reduce it to a unit rate. So 4,320 drops is still 4,320 drops. Nothing up there is just a 1 to multiply that by. On bottom, we have 12 times 60 minutes, which is 720 minutes. Now I divide this out. The 4,320 divided by 720 gives us 6, that is drops per minute. And once again, this was the maximum dose. Notice the time frame's already been figured in here, so we don't have to adjust for any sort of time frame. That was the maximum dose of 15 milligrams per kilogram. To titrate for the minimum, we take that 6 drops per minute, at 15 milligrams per kilogram on bottom, and 14 milligrams per kilogram on top. So again, these units cancel out. We'll take our 6 times 14 and divide it by 15 to get 5.6 drops per minute is our minimum recommendation. So our recommended range is from 5.6 drops per minute to 6 drops per minute. So these calculations can get deeper than this. We've seen them come into different levels before where they're just straight calculations where the recommendation was in a number of units, so we had to go from units to milligrams, then to milliliters, and on down the line. We won't get quite that rigorous with it on our tests here, so I'm going to leave that example off. But I want to talk about some other characteristics. So we said one of the patient characteristics was weight that we use to calculate the dosage. Another common characteristic for skin conditions, burn patients would be one, eczema and some other skin conditions. We would base the medication on body surface area. So I want to do one example of this quick before we call it a day, and then we'll look at this more next week. But let's look at, same type of setup. The doctor's order is to administer the recommended dose. And so we look at the recommendation, and the recommendation says 35 to 40 milligrams per, now this is, when it was based on weight, this was per kilogram. For body surface area, it's going to be per square meter or meter squared of body surface area. And there's a time frame of 12 hours here. We'll look at the label of the bottle. And this medication is constituted That's 25 milligrams in every 4 milliliters of fluid. And we have a patient. Now again, we're not giving their body weight, we're giving their body surface area of 0.9 meters squared. Next week, we'll look more about how you get that body surface area. Obviously, most patients will know their weight, and you can find it really quickly by throwing them on a scale if they don't know it. Not too many people know their body surface area. So we'll start with the 0.9 meters squared for now. And we'll get rid of meters squared. We'll use the maximum again, 40 milligrams per 1 meter squared. So the meters squared cancel out, we're in milligrams. And as usual, our next step is to get rid of milligrams and get to milliliters. We have 25 milligrams in 4 milliliters. So the milligrams cancel out. So on top here, we have 0.9 times 40 times 4, giving us 144 milliliters. On bottom, we have 25. So we'll divide that out. 144 divided by 25 is 5.76 milliliters. Now we need to bring that time frame back in. That is every 12 hours. We need to find the minimum there. Or this was the maximum. So we're going to do the titration here, starting with the 5.76 milliliters. That was based off of 40 milligrams per meter squared. We want to go to the minimum of 35 milligrams per meter squared. So the milligrams per meter squared cancel out. It's just going to be the 5.76 times 35 divided by 40. It's 5.04. So that, of course, again, is the minimum recommended dosage. To give us a recommended range of 5.04 milliliters, that was per 12 hours. So 5.04 milliliters every 12 hours to 5.76 milliliters every 12 hours. As I mentioned, we will spend way more time working with body surface area next Wednesday. Our next class now, since we have the Easter holiday here with Friday and Monday coming up, our next class will be next Wednesday on the 12th. For now, homework is going to be on page 188 through 190, problems 1 through 21, the odds. With that, y'all have a great weekend, and we'll see you all next week on Wednesday.